So today in class we talked about how we can approximate a best fit line for a scatter plot. And what this allows us to do is it allows us to actually come up with an equation or a formula that we can use to make predictions about other data values that may not be graphed on your scatter plot. It's a four-step process. The first thing you always have to do is start with a scatter plot. And so we either need to use one that we're given or draw the one based on the data points we're given. After you get the scatter plot drawn, you're going to sketch the line that appears to follow most closely the trend given by the data points. What that means is you want to draw in a straight line that best shows the pattern your points are following. Now, it doesn't have to go through any of your data points. It can. A good rule of thumb is you want about the same number of points on top of the line as you have on the bottom of the line. Now, once you have that line drawn, step 3 says choose 2 points on that line and estimate the coordinates, or the ordered pair, of each of those points. Okay? They do not have to be original data points. They can be, but they don't have to be. You want to pick 2 points where it's really easy to get the ordered pair for them, like they cross right at a grid mark. And then once you have those 2 points, we are going to write an equation of the line. Now, the easiest form to work with when you're working with a line is slope-intercept form, which is y equals mx plus b. And we talked about this back in chapter 2, where m is your slope and b is your y-intercept. So let's look at the next page and do an example together. If you look at this problem up here, it says the table shows the U.S. daily oil production in thousands of barrels X years after 1994. So the first thing we're going to need to do is make our scatter plot. Now notice your x coordinates are just going by ones, and so that's what I'm going to count by, except I'm going to skip a line in between just to space it out a little bit. It makes the graph, I think, a little bit easier to see. Now if you look at your y coordinates, those are all pretty big. I would suggest you count by 500s or 1,000. Just use a scale that's appropriate for the problem. I'm going to count by 1,000, but again, I'm going to skip a line in between just to space it out a little bit. And then I'm going to plot my points. You just go over to x, up to y, and plot your point. So at 0, we're going to be at about 6,600. At 1, we're at 6,560. Year 2, 6,470. Year 3, 6,450. Oops, wrong place. Year 4, 6,250. $58.80. Shoot, $58.20, $5,800, and $57.50. Okay, and so minus the ones I did incorrectly. You can see that our data definitely has a negative correlation, and it probably assigned a coefficient of -1 because they're very close to making a straight line anyways. So here are your data values. Now what you're going to do is take some kind of straight edge. You do have to use a straight edge because you want the line to be completely straight, okay? And you're going to place your straight edge in the place that you think best shows the patterns of your data values. So I'm going to put mine about like this. And you just draw a straight line. Okay? And what we're going to do is we're going to write an equation for that line, okay? But the first thing I need to do is I need to find 2 points where it's really easy for me to get your ordered pair. All right, so just looking along the line, mine seems to cross really nice right here. That is the point 0 and 6,500. So I'm going to pick that one. Going along the line, another place that seems to cross really nice. Well, it goes through this point down here, which is the data point. I can use that as well. Okay. Everybody's going to pick something different because everyone's line is going to be approximated in a little bit different place. You just have to pick 2 points where you can easily get an ordered pair. Now what I'm going to do is I need to write an equation that's in the form y equals mx plus b. And to do that, I need a value for m, I need to find the slope, and I need a value for b. To find the slope, we are going to actually use our slope formula, which if you remember is y2 minus y1 over x2 minus x1. And so for me, I'm going to do 5750 minus 6500 over 8 minus 0. And when I do that on the calculator, I get negative 750 over 8, which gives me a slope of negative 93.8 approximately. And again, your numbers are probably not going to be this. You will probably have other numbers, and that's okay. So now that I've approximated the slope, I need to solve for b. I'm going to choose one of my ordered pairs. It doesn't matter which one. I'm going to pick that one. I'm going to plug that in for x and y, and I'm going to use that to solve for my y-intercept. I'm going to plug in y as 5750 equals my slope times my x value, which is 8, plus b. So when I multiply that out, and then when I add that to the other side, I get about 6500.4. If I hadn't rounded up here, if I just left it as 0.75, that would have come out as just 6500. You could also tell that on this problem, because I chose 0, 6500, that's what your y-intercept should be. But you should always calculate it, especially if you're not using that point as a y-intercept. Now, I'm finished. I have an equation. My equation for this best fit line is going to be y equals negative 93.8x plus 6500.4. And that is how you approximate an equation for the best fit line. Now, in class, we also looked at how you can come up with this equation on the graphing calculator. It's much quicker. Unfortunately, I forgot to bring a graphing calculator home tonight, so if you have a question and you were absent today, please come see me tomorrow and I will walk you through how to do this on the graphing calculator. It's very simple.